Hi guys, morning. This time I will talk about electron configuration. The first method that we're gonna learn about is the full electron configuration notation. So let's take a look at this first example. The instructions are: write the full electron configuration notation of the following elements: lithium, carbon. Also, write the electrons in the outer energy level. Now, for this topic, we're gonna make use of the image that I already sent it to the group. That is the sublevels of energy. Okay, I wrote them over here. S represents 2 electrons, P represents 6 electrons, D is 10 electrons, and F is 14 electrons. Now, as the name says, electron configuration notation is a way to express the electrons that are present of the elements. Now, sorry. Remember when we were learning about the subatomic particles, we said that the atomic number tells you the number of protons, but also the number of electrons. So, first of all, you're gonna make sure that you have everything you need. You have your electron configuration table, and you have your periodic table with you. Now, I don't have the periodic table with me because it will be really difficult to show you the elements individually. So I made them apart, like you can see over here. So we're gonna start with the topic. The first example that we're gonna do is lithium. So, how do we solve this type of problems? I will say that we solve them easily. Okay, first of all, what we do first is to write the element symbol and the number of electrons. What is the number of electrons? The atomic number. So for lithium, the atomic number is 3, so the electrons are 3. So we're gonna take the table and we start from here. And we say, okay, the first level of energy is 1s, and s is 2 electrons. So we say 1s2. But I don't need 2 electrons, I need 3. So as I need more than 2, I will continue to the next sublevel. So I follow the pattern right here, and I continue with 2s. But what happens if I use the 2 electrons? I will have 4 electrons in total. And lithium doesn't have 4 electrons. It has only 3. So instead of writing 2 over there, we're going just to write the electrons that are remaining. In this case, 2 plus 1 makes 3. And this is the total electron configuration for lithium. Now it says, this is the electron configuration notation, and now electrons in the outer level. Now, which one is the outer level? The highest period. The period is the number, the coefficient that you see here. So this is the greatest period. So how many electrons do we have in this period? 1. So electrons in the outer energy level is 1. That's why lithium is part of the first group. Now let's see carbon. The symbol, the atomic symbol is C, and the electron is equal to the atomic number, and it's equal to, according to the periodic table, 6. So that means that we need to reach 6 electrons following this path. So let's take a look. Remember, S is for 2, P is for 6. Now we always start in this point. So we say, in the first level, in the first period, I have 2 electrons. I follow the path and I go to the second period. Now what do I have here? I have 2 electrons, and then I need to follow the path again, because I just have 4 electrons here and I need 6, so I need 2 more. So I will have to follow, and I realize that it goes to P. Now what happens when it's P? P is equal to 6. But if I add them all, I will have 10 electrons. But I just need 6. So instead of writing 6, we're going just to write the electrons that we really need to reach 6. I have 2 and 2. I have 4. So I need 2 electrons to reach 6. Now, this is the electron configuration, because if you add them all, 2 plus 2 plus 2 is equals to 6. Now, how many electrons? This is the electron configuration notation. Now, how many electrons are in the outer energy level? Let's see. The outer energy level is the greatest period, which is 2. Now, in the second period, I have how many electrons? I have 2 and 2. 2 plus 2 equals 4 electrons. And this is how we do these exercises. Okay, let's continue. The next example is chromium. First of all, we need to write the element symbol, which is Cr. Now, the atomic number is the number of electrons, and is, as you can see, 24. That means that we need to reach 24 electrons following all this path. Now we always start with 1, S2. Now I'm missing 22. I continue with 2, S2. After 2s2, it goes 2p6. After 2p6, I go to 3s2. After 3s2, I go to 3p. 3p6. Now I need to make sure that I don't have more electrons that I need, so I'll be counting. I have 2, 2, 2, 6, and 6, 12, and 6, 18. That means I need 6 more electrons. So I continue. After 3p6, it goes 4s2. I'm missing 4 electrons. After 4s, I'm going to 3d. And I'm gonna write it in the period, okay, in its own period, not here. 3d. Now, if you add them all, you know that d means 10. But if you use 10, you will have more electrons than needed. So remember, you must be counting. 2, 6, and 6 is 14, and 6 is 20. So that means that we just need 4 electrons instead of 10. So just use the 4 electrons over there, not the 10. Now, this is the full electron configuration. And now I want to know the electrons in the outer energy level. So, the outer energy level is the greatest period. In this case is 4. How many electrons I have in the greatest period? 2. 2 electrons for chromium. Now for selenium, as you can see, we have a number that is a little bit greater. So we start doing by doing the same. we have the symbol that is Se, and we have the atomic number that is equal to the number of electrons, that is equal to 34. Now, we start by writing the electron configuration notation first. We always start here, and we say 1s2, 2s2, 2p6, 3s2, I continue, 3p6, 4s2, 3d10. Let's count how much we have. 2, 2, 2, 2, it's 8, and 12 is 20, and 10 is 30. That means that I need 4 electrons, so I continue with 4p. But instead of writing 6, I'm just gonna write what I need. I need 4. So now we always need to make sure that we add them correctly. So I have 2 plus 2 plus 2 plus 2. I have 8 plus 6 plus 6 plus 4 plus 10, 34. So it's done. Now, how many electrons are in the outer energy level? Let's see. The outer energy level is 4. How many electrons I have in this level? I have 2 and 4. 2 plus 4 equals 6 electrons. For the next example, I have copper. So first of all, we write the atomic symbol, which is Cu. Cu, guys. You should say Cu, and the atomic number, or the number of electrons, is 29. That means that we need to reach 29 electrons during this process. So we always start here, and we say electron configuration notation. We say 1s2, and we follow, and then we continue 2s2. We follow, we continue 2p6. We follow 3s2. We follow to 3p6. We follow to 4s2. We follow to 3d10. Okay, now I stop because I think I have more than I needed, so I need to count. 2, 2, 2, and 2 makes 8, plus 6 and 6, 12, plus 10, I have 30. And I needed just 9, so I will take the last one that I wrote, that is this one. Instead of 10, sorry, I just need 9 electrons. So you need to be careful. You need to be careful in that part. Now, this is the full electron configuration notation. And the electrons in the outer energy level are going to be last period, which is 4, and the electrons in the same period, that is 2. 2 electrons, this is the answer. Now let's do one last example, that is rhodium. Rhodium, the atomic symbol is Rh. And the number of electrons is equal to the atomic number, and that is equal to 45. That means that we need 45 electrons. So we start with the, I'm gonna write it here. Okay, we start right here, and we start by building the electron configuration notation. We always start here, so we say 1s2, we follow the path, 2s2, we follow the path, 2p6, sorry, I will correct this. There you go. Okay, sorry, I have to make a change in the sheet here. Okay, we continue after 2p6. We continue with 3s2. We continue with 3p6. We continue with 4s2. We continue with 3d10. I know that when I write 3d10, I know I have 30. I just know it by memory, okay, by heart. After 3d10, so that means that we need 15 more electrons. So we continue with 4p6. We continue with 5s2. So at this moment, I know that I'm very close to 45. So I will start by counting everything I have. We are in this point, okay? We are in 5s. So I have 2, 2, 2, 2, and 2. I have 10 electrons over here, plus 6, 6, 6, 18, plus 10. So far I have 38 electrons. That means that I need to reach 45, I need 7 electrons. So from the following number, that is after 5s, I have 4d. Instead of 7, or instead of 10, I'm gonna write 7. And then make sure that you have everything correct. So we make sure that all the additions are going to give you the same 45 that we need. So 2, 2, 2, 2, and 2, it's 10 plus 18 plus 17. 10 plus 18 plus 17, look, 45. So we did it right. Now, that is the electron configuration notation. Now, what about the electrons in the outer level? Again, we'll take a look of the last period. The last period is the one in the bottom, which is 5. How many electrons I have in the bottom? 2. So electrons in the outer energy level is 2 electrons. And this is it, guys. I hope you have understood. If you have any doubt, feel free to send me a message. Take care. Bye-bye.